Hello guys, I hope you are all doing well. In this video I will show you how to solve the problem non-overlapping intervals. So let's get started. The problem asks us to find the minimum number of intervals that need to be removed from list of intervals so that no intervals overlap. So let's say we have this list of input. To solve this problem, we're going to use the greedy algorithm technique. So we're going to start by sorting the intervals by their end time in ascending order and then iterate throughout the intervals in that order. So why we sort the list by the end value? The greedy approach works by processing the intervals in order from least to greatest end time. And that's gonna help us to find the minimum number of intervals that need to be removed. It means for each interval, we only keep an interval if its start time is greater than or equal to the current end time. If the start time is less than the current end time, we know that the interval overlaps with the current interval, so we skip it and increment a counter. So in this example input that we have, the first interval, the start time is 1 and the end time is 2. So we check if the start time is greater than or equal to the current end time, which will be at the beginning a minimum float value. If it's bigger, we update the current end time to be the end time of the interval. If it's not, we increment a counter. And at the end, the counter holds the total number of intervals that need to be removed to ensure that no intervals overlap. And the function returns this counter as a result. So that's it guys, let's jump at coding the solution. First we initialize a variable that's gonna be hold the number of intervals that we're gonna delete, and we initialize a variable called current end, which is gonna be equal to a minimum float value. Then we sort the interval by the end time in ascending order with the help of the lambda function, and we iterate throughout the intervals. If the start time of intervals is greater than or equal to the current end, we update the current end to be the end time of the interval. Else we increment the counter by 1. And finally we return the counter variable. So the time complexity of the solution is O of n log n, where n is the number of intervals. This is because the function performs a single pass throughout the interval list, and the list is sorted using a comparison-based sorting algorithm, which has a time of complexity of O of n log n. And as we know, in complexity analysis, we drop the less significant term, so we keep the O of n log n. And the space complexity is O of 1 since the function does not use any additional data structures to store the intervals or the sorted list. Thanks for watching. See you in the next video.